Welcome back to the classroom. Today's topic is the study of TDA4651 multi-standard color decoder. This video is sponsored by BuyMote shopping app. BuyMote e-shopping application is one of the online shopping app. The TDA4651 is a single chip that can decode multiple color standards like PAL, SECAM, and NTSC. It has negative color difference output signals. These output signals are then sent to the TDA4661, which is a switched capacitor delay line. Next is the functional description of TDA4651. The TDA4651 is an integrated circuit that has all the necessary functions for identifying and demodulating PAL, SECAM, NTSC 4.43 MHz and NTSC 3.58 MHz signals. When an unknown signal is input, the circuit needs to determine the standard for the signal by sequentially activating the appropriate input filter, crystal, and demodulator. Once the signal is identified, the circuit activates the color and hue control for NTSC reception, and the two color difference signals are available at the outputs. The identification circuit can differentiate between NTSC signals with color carriers frequencies of 3.58 MHz or 4.43 MHz. Next is chrominance amplifier. The chrominance amplifier has an input that is not symmetrical. The input signal needs to be connected to an AC source. The input stage includes a differential amplifier followed by a gain control stage and another differential amplifier with lateral PNP transistor that act as a level shifter. The gain control stage consists of two ACC rectifier circuits. One circuit is activated during SECAM reception or during the SECAM part of the system control scanning, while the other circuit is activated during the burst when PAL or NTSC signals are received or during the PAL and NTSC parts of the system control scanning. The DC potential of the symmetrical signal connections to the demodulators is regulated to the same level using a working point control stage. Next is the reference oscillator. The oscillator used for PAL and NTSC operates a frequency that is twice that the color carrier. This is then divided to ensure that the reference signal has the correct phase relationship with the PAL or NTSC demodulator and the identification component. Next is demodulators. To demodulate the color signal, three demodulators are needed. Two demodulators are used for both PAL and NTSC signals, while one is specifically for SECAM signals. When receiving NTSC, the symmetrical signal is sent to differential amplifier stage with the correct gain. From there, the signal goes into two demodulators, each consists of 4 transistors. During NTSC reception, the PAL switch between the differential amplifier of the channel and corresponding demodulator is disabled. The transistors are controlled by the appropriate reference signals to switch on and off. When receiving PAL, the symmetrical signal is sent to the same differential amplifiers and the PAL switch is active. The SECAM demodulator is a combined demodulator that inserts artificial black levels alternatively every second line and during the line and field flyback. Next is clamp. The signals are being filtered and the black level is fixed at a constant DC level during the burst gate pulse. This occurs every second line for SECAM signals when the artificial black level is present. Following the clamping stages is the de-emphasis for SECAM signals, and just before the output stages are the color killed and blanking stages. The blanking level and black level are the same as the clamping level. Next one is the identification. The identification section consists of three demodulators. The first demodulator operates during PAL and NTSC identification or reception and is only active during burst clamping. It uses the phase as the reference signal. The second demodulator operates during SECAM identification or reception and is active during a portion of the burst clamping time. It uses the same signals as the SECAM demodulator, which is not active during field flyback. These two demodulators are followed by a H2 switch that rectifies the demodulated signals. As a result, an identification signal is generated that is positive for a PAL signal during the PAL scanning phase, for a SECAM signal during the SECAM scanning phase, and for a PAL signal during the NTSC 4.43 scanning phase. The scanner then switches back to the PAL scanning phase to prevent a PAL signal from being mistakenly identified as a SECAM signal. This is the basic study of TDA4651 multi-standard color decoder. Thank you for watching.